Hello, my name is Shane Colpia. My lab took place on Wednesday, April 15 at 12 o'clock. I will be demoing Lab 11, an encryption unit for serial communication. This circuit is meant to encode information in a certain way so that users can send it without having to worry about others stealing that information, since it would be encoded in a way only known by the users. The specific encryption is made so that whenever the sequence 011 is seen, every number after that will be complemented until the sequence 0010 is seen. The information will continue to be encrypted in this manner as long as there are bits still coming in. There are two inputs to the circuit. One is this push button, representing the clock, and the other is the first switch representing the bit coming in. Once the push button is pressed, the bit enters the sequence. There is only one output, which is the first LED light, which represents the status of the latest bit in the sequence. I will demo this circuit by going through the sequence I have written over here. The diagram next to it describes how the encryption works, as well as the circuit over here. Before the encryption starts, that is, before 011 is seen, the bits entered will be displayed normally. However, once the final bit of the encryption sequence is entered, the bits entered, including that final bit, will be displayed as a complement. Ones will be zeros and zeros will be ones. This will continue until the sequence 0011 is seen. So the first number in the sequence is 1, and the light is still on, so when I flip the switch, it is in the 1 position. Now I press the push button, the light should remain on, and it did. So the next two numbers are zeros. So I'm going to flip the switch down to the 0 position, and then press the button twice. Here's the first 0, and then here's the second 0. The first 0 turned it off, and the second 0 remained off. The next three numbers are ones. The first one I will switch on, and then I'll press the button. Now this 1 turns it on. Then the second one completes the sequence of the encrypted code, and that number will turn it off since it will cause it to be complementary. And there it is. That's the second one. Now here's the third one. It will remain off since it's still a complement. The next number is a 0, and since it's still complemented, the light will turn on. Right there. The next bit is a 1, which will cause it to turn off, and then the next 5 are zeros, and all of them will cause the light to turn on. Here's the first one, second, third, fourth, and fifth. The light still remains on, and here's the 1, the light turns off. Now the final bit in that sequence, 0010, will cause the light to remain off, since it's no longer complemented. And there it is. Now, the next number is a 1, and there it is, it turns on, no complements. The next two numbers are zeros, 0, 0, which turns it off. And then the next number is a 1, and then the next number after that is a 1, but that also completes another sequence for the encoded circuit. So, when I press this button, the light should turn off, since it is complement, and it did. The next number is a 0, causing it to turn on, and the final number is a 1, causing it to turn off. This is the encoded circuit that I was assigned. Thank you for watching.